jhat 塾
Please hit subscribe.
This problem appears at the qualifying examinations for applicants for Japanese government or MEXT scholarships 2020. This problem is from the 2020 College of Technology Mathematics questionnaire. The answer key and the original questions are linked in the description.
We are asked to remove the absolute value symbols, and then we just have to simplify the remaining expression. And to do that, we need to recall a certain property of the absolute value. This is how we denote the absolute value of any real number a. That is, we have two vertical bars around it. And the absolute value of a is algebraically defined as the principal root of the square of a. For example, if we want to get the absolute value of a equals 3, then we first need to square 3. So 3 squared is 9, and we get the square root of that. The square root of 9 is 3, so the absolute value of 3 is simply 3. The same is true for when a equals 0. We get the square of 0, which is just 0, and we get the principal root of that, which is again 0. So the absolute value of 0 is just 0. For a equals -3, we first square -3. We get 9. Then we get the principal root of that, which is 3. So we say that the absolute value of -3 is simply 3. From this definition, we can extract the following property. We can remove the absolute value symbols and just replace it with the following. If a is positive or 0, then we don't have to add anything. We can just remove the absolute value symbols. If a is negative, then we can remove the absolute value symbols, but we have to attach a negative sign here. And this is useful when we are doing calculations because we do not have to deal with the square root sign or with the absolute value sign. So we can just do simple algebra here. Now, if we try to apply this with our example here, let's try to get the absolute value of 3. 3 is a positive number, and so we just remove the absolute value signs like here. So the absolute value of 3 is simply 3. The same is true with 0. Because 0 is greater than or equal to 0, we can just remove the absolute value signs, and we're left with the absolute value of 0 is just 0. For -3, we can remove the absolute value symbols, but we have to attach a negative sign here because -3 is less than 0. But the negative of -3 is simply +3. So again, we get that the absolute value of -3 is just 3. The answers we get from this using the property here is the same as the answers we get from here using the definition here. The original problem gives this, and then we need to add this and this. And so, to be able to use the property here, we need to know first whether this is positive or negative, and the same is true for this expression here. And when we know that, we can remove the absolute value symbols and we can just do a simple addition or subtraction. So let's begin with this expression. Let us try to find out whether this is positive or negative. First, we know that pi is 3.141592 plus something, and it's irrational, so it doesn't really repeat or end. But we know that that is greater than 3, and 21/7 is 3, so we know that pi is greater than 21/7. Furthermore, we know that 21 is greater than 20. Therefore, 20/7 is less than 21/7. And if we remove this middle term here, we can see that 20/7 is less than pi. And so, if we move this bit 20/7 to the other side, we are left with this inequality. Strictly speaking, this should have been just greater than, but we added the greater than or equal to symbol instead, so that it will conform to this inequality here in the first case. And by doing that, we see that pi minus 20 over 7 is positive, so it's with this case here, and so we can just remove the absolute value symbol and we just get the expression here. And now we move to the second expression, which is pi minus 23 over 7. We know of the approximation pi is approximately equal to 22 over 7. And in fact, 22 over 7 is slightly greater than pi. We see that the third term here, or the third digit here is 2, when for the real pi, that's actually 1. So that's 141692 for the actual value of pi. And so we don't even have to know the rest of this. We just need to know that this is 1 more than the actual decimal value here for pi. Now we can say that 22 over 7 is slightly greater than pi. So that's what we have here. But we also know that 23 is greater than 22. And so 23 over 7 is greater than 22 over 7. Therefore, we can say that pi is less than 23 over 7. And if we move the 23 over 7 to the other side, we get this. We see that pi minus 23 over 7 is less than 0. In other words, it's negative. And so we get this second case here. And so to remove the absolute value symbol, we need to attach a negative sign to this expression here. And if we distribute that negative sign, we get 23 over 7 minus pi. This was the given, the original given, and now we can just remove the absolute value symbols according to what we found out in the previous slide. So this one just becomes this, and this one becomes this. And conveniently, the pi's cancel. We are left with 23 over 7 minus 20 over 7, and that is just 3 over 7. If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!
Please hit subscribe.